Hey guys, in this video I'm going to run you through all the solutions for the AQA A-Level Paper 1 for 2024. Every question is going to be timestamped so you can easily skip to a question you want to look at or rewatch one. Hope this helps. Going straight for question 1, it says, can we find the coefficient of x in this expansion? So to do that, let's just think about what combinations would multiply to give us an x. Well, first off, it would be the 3x and the 1, so that would be a plus 3x. And it would be the minus 2 and the 4, that would be a minus 8x, so that would be a minus 5x, so the coefficient would be minus 5. Next it says the function f is defined as f of x equals e to the x plus 1 for all x element of the real numbers. Find an expression for the inverse function of x. So we're going to do this algebraically to make sure we get it right. We could write that, and then if we rearrange for x, we'd get e to the x equals y minus 1. Then x is the natural log of y minus 1. And then to get the inverse, we just swap the x and y around, so that'd be y equals the natural log of x minus 1. That'd be the first option here. For question 3, we're given this expression. It says we can write it in this form. Can we find the value of a? Well, our expression is a quadratic over a linear, so we could long divide to change the form. So let's do that. So 3x minus 5 going into 12x squared plus 3x plus 7. So it would be 12x squared divided by 3x. That would give us a plus 4x. And actually, we can see that's going to be the answer from them immediately. We could work out b and c, but we don't need to. So the answer is just going to be this 4 here. For question 4, it says one of the diagram shows the graph of y equals arc cos of x. Identify which graph it is. Well, arc cos of x is the inverse of cos x. So that would be a reflection of cos x in the y equals x line. And that means like the x and y coordinates get flipped around. So if we think about this point here is 0, 1. And it would become 1, 0. So one of these, like the graph we want must go through 1, 0. So that means it could be either the bottom 2, can't be the top 2. And if we think about it, like this point here, when we reflect that, that would become 0 pi on 2. And it's going to kind of come out looking like this, isn't it? And then it's going to pass through the y-axis. If we were to like reflect all this, it would actually, this would like reflect to actually pass through here. So it's going to go through and then up. So that's the fourth option here. Going for question 5 now. It says solve the equation sine squared x equals 1. Well, we can reduce that down to sine x could equal 1, or sine x could equal minus 1. And it wants the solutions from 0 to 360, so just in the first cycle of the sine graph. Well, that happens where sine x equals 1 once between 0 and 360. That's at 90 degrees. And then it's minus 1 once at 270 degrees. Going to question 6, it says, use the chain rule to find dy by dx when y equals x cubed plus 5x all to the 7. So when we're doing the chain rule, we need to differentiate the inside first and then the power. So we differentiate the inside, that would become 3x squared plus 5. And then if we think about x to the 7, that would go down to 7x to the 6. But it's really this x cubed plus 5x to the 6, like that. And then let's just make that look a little bit nicer. That'd be 7 times 3x squared plus 5 times x cubed plus 5x, all to the 6. Going to question 7, it says, show that this fraction can be rewritten as the bottom fraction. The thing I notice is that there's no surd or no square root in the bottom, so we can think of this as just like rationalizing the denominator. So to do that, we're going to take one of the terms in our denominator of our fraction and change the sign. So I'm going to change the sign of the root 2n, and then we're going to multiply by that on the top and bottom to get rid of the surd in our denominator. And just to remember why we're allowed to do that, that in brackets there is equal to 1. Multiplying by 1 doesn't change the fraction, so it's still the same overall fraction. Then expanding out, because we'd have to do double brackets here, twice on the top and bottom. So we'd have 3 times 1, that's 3. 3 times minus root 2n, let's call that minus 3 root 2n. Then we've got root 8n times 1, so that's plus root 8n. And then we've got root 8n times minus root 2n. So let's call that minus root 16n, and we'll simplify that in a minute. Then on the bottom, we're going to have the 1 times the 1. The root 2n times 1 and the 1 times minus root 2n is going to cancel completely, so we can ignore those. And then root 2n times root 2n, that's going to be minus 2n on the bottom. So if we collect everything we can in the top, well, we've got 3, and then root 8n, we could think of that as, well, it's root 4 times root 2n. That's really plus a 2 root 2n. And then that combines with this guy to just give us a minus root 2n. You have minus root 2n. And then let's see here. The minus root 16, and we could think of that as root 16 times root n. So that's just a minus 4 root n. Oh, sorry, it should have been n squared, shouldn't it? Because it was 8n times 2n. That's root of n squared, which is actually then just an n, isn't it? So minus a 4n, and then on the bottom we've got 1 minus 2n. And we're almost there. We just notice like our things are the other way around, so they've got 2n minus 1 in their denominator, but we can fix that just by multiplying the top of bottom by minus 1. So that would give us 4n minus 3 plus root 2n over 2n minus 1. Going now to question 8, it says the first 3 terms in ascending powers of x in the expansion of 2 plus kx to the 5. Find the first 3 terms in the expansion of 2 plus kx to the 5, where k is a positive constant. So that's an integer power, so we can use the a plus b to the n form, which is in the formula booklet. So writing that out, we would have, for our expansion, for 2 plus kx to the 5, we're going to get 2 to the 5 plus 5 choose 1 times 2 to the 4 times kx to the 1. And then we'll have 5 choose 2. 5 choose 2. And 2 cubed, and then kx all squared. 2 choose 5. Sorry, 2 to the power of 5. Is 32. 5 choose 1 is 5. So that's going to give us 5 times 16. Let's just do it all on the calculator, actually. 5 times 2 to the 4 times kx. That'd be 80 kx. And then 5 choose 2 is just 10. So it's going to be 10 times 2 cubed, which is 8. So it'll be a plus another 80. But then k squared, x squared, squaring that final bracket. And then that's the first 3 terms that they asked for. Then it says, hence, given the coefficient of x is 4 times the coefficient of x squared, find the value of k. So the coefficient of x is 80k. And they're saying that's 4 times the coefficient of x squared, so 4 times the 80k squared. So that's actually a quadratic in k. First off, let's cancel a factor of 10, or actually a factor of 80 we can cancel, can't we? So that would be k equals 4k squared. Then we'd have 4k squared minus k equals 0. Factorizing out the k, we'd have 4k minus 1 left, which would mean k could equal 0 or a quarter. But it says k is a positive constant, because this would be really boring if k was 0. It would just be 2 to the power of 5. So the actual answer is going to be k is a quarter. Moving on to question 9, it says, show that for small values of theta measured in radians, cos 4 theta plus 2 sine 3 theta minus 2 tan 2 theta can be expressed as that. So we got to remember our small angle approximations. They're in the formula booklet, but I'll write them out here. So cos x is approximately 1 minus x squared over 2, and tan x and sine x are both approximately equal to x for small values of x. But what we've got to watch out for here is like x is different in each of these. So for cos 4 theta, it's going to be the x is 4 theta, so it's 1 minus 4 theta squared over 2. Then we've got 2 lots of, in the sine, the x is 3 theta, so 2 lots of 3 theta, and then it's 2 theta in the tan, so it's going to be minus a 2 theta. Simplifying that up then, we've got 16 theta squared over 2, that's 8 theta squared, but it's a minus, so it's minus 8 theta squared. Then we've got a 2 times 3 theta, that's 6 theta, minus 2 theta, that's plus 4 theta. And then we've got the lone 1, so just plus 1 on the end. Then for part B, it says, use your answer to part A to find an approximation for cos of 0.28 plus 2 sine of 0.21 minus tan of 0.14. So first off, let's see that that's actually this here. And they've actually put in some kind of value of theta. So let's think about what that angle is. Well, the 0.14 needs to be 2 theta. So that would mean theta is 0.07. And just checking, checks out, 3 lots of that would be 0.21, and 4 lots would be 0.28, so that's definitely right. Then we just need to plug that value into our approximation. So it would be minus 8 lots of 0.07 squared, plus 4 lots of 0.07, plus 1, so plug that in the calculator. They want it to 3 decimal places. We get 1.24. Sorry, just a correction there, guys. That's obviously not 3 decimal places. To 3 decimal places, looking at the calculator, it'd be 1.241. Sorry about that. Question 10 then says, an arithmetic sequence has 300 terms. The first term of the sequence is minus 7. The last term is 32, and can we find the sum of the 300 terms? So that's just going to be using the Sn formula. So Sn is n over 2, 2a plus n minus 1 d, where n is the number of terms, so 300. A is our first term, minus 7, and d is our common difference. Sorry, we don't know the common difference yet. So the first term is minus 7, and the last term is 32. So we're going to need to work out the last term. So to find the common difference, we can think about that last term. So that would be u300. Well, let's write the nth term first out. So that's a plus m minus 1d is the nth term formula. And we know the 300th term, u300, would be then minus 7 plus 299 lots of d, and we actually know that's equal to 32. So d then must be 32 plus the 7. That makes it 39 over 299. So then we can just go and plug into our formula. So S of 300 is going to be, use our calculator for all of it, it would be 300 over 2, open bracket, 2 times the minus 7, plus 299 lots of the 39 over 299, which gives us 3,750 total. Part B then says, a school holds a raffle at its summer fair. There are 9 prizes. The total value of the prizes is 1,260. The values of the prizes form an arithmetic sequence. Okay, so that's like the number of terms, n. This is the sum of the 9 terms. The top prize has the highest value, and the bottom prize has the least value. The value of the top prize is 6 times the value of the bottom prize. Okay, so if we think about if this is an arithmetic sequence, the bottom prize would just be the first term of our arithmetic sequence, and then the top prize would be the 9th term, so that's going up the sequence all the way up to a plus 8d to get to the 9th term. So if we use that information, what would it say? The value of the top prize is 6 times the value of the bottom prize. So that would say a plus 8d must be 6 lots of a. So we can simplify that a little bit. That would say that 5a equals 8d. And I imagine we're going to want to substitute this into another equation, so I'm just going to preempt that and rearrange for a. That'd be 8d over 5. And we haven't used this information yet, so the Sn is the sum of 9 terms would be 9 over 2 2a plus n minus 1d, so that'd be 8 lots of d. And we actually know that that is 1,260. So yeah, we've got 2 equations now with 2 variables, so we know we can solve simultaneously. So let's sub in the a. So we'd have 9 over 2. Then it would be 2 times 8 over 5. That would be 16d over 5. Plus 8d equals 1260. So let's use our calculator to simplify that. So 16 over 5 plus 8 gives us 56 over 5. Then we can divide that by 2 and multiply by the 9. So that's 252 over 5d. Is the 1260. So if we do 1,260 divided by our 252 over 5, that answer I just got, so use the ANDS button, we get the common difference is just 25. And if we go back to here and find a, that means a would be that times 8. So answer times 8. And then divide that by 5. That would be £40. And then to get the value of the top prize, well, that was the a plus 8d from the beginning. So top prize is going to be 40 plus 8 lots of 25. So take our answer from here, 40, and add 8 times 25. That gives us £240. Continuing to question 11, it says it is given that f of x is this cubic function here, where a is between 0 and 6. Sketch the graph below. So first off, they've given it to us in a nice factorized form, so that tells us the roots. The x on its own means there must be a root at 0. The x minus 6 means there must be a root at 6. And then the x minus a means there's a root of a, which is between 0 and 6 somewhere. So I'll just plop that down in the middle. And then it's a positive cubic. So for big negative values of x over here, it's going to become from negative infinity. And then for big positive values of x, it's going to go off to positive infinity. Then the graph's going to have to look something like this, going between all our roots. Then part B says, can we sketch the same graph on the axis? Can we sketch the graph of f of minus 2x on the axes below? So minus 2x takes any xy point, and it's going to multiply the x by minus a half, or divided by minus 2 if you want to think of it like that. So we can just transform all our roots. So 0 is not going to change. That's just going to be 0 still. And then this root here at a, sorry, I should have written that there. That would have gone to, that's going to go to minus a half a. It'll be there. And then 6 is going to go to minus 3. And then just to actually think about what minus 2x does visually, well, it's a stretch as well as it's a reflection in the y-axis. So we're going to reflect all this over here. So then doing that and making it pass through our roots again, it's going to look like this. Carrying on to question 12, it says the terms un of a periodic sequence are given by this recurrence relation. We're given the first term, and can we find the next 3 terms? So to get u2, I'm just going to plug that into the formula. So u2 would be minus 6. Plug u1 into the formula, sorry. So it'd be minus 6 over 3. That's going to be minus 2. And to get u3, we do the same thing, but with u2. So it's going to be minus 6 over minus 2, which is going to be 3 again. So now that's the same calculation we did before. So we already know that u4 is going to be minus 2 again. So what is our sequence doing for part B? Well, it just goes 3, minus 2, 3, minus 2, so on. So that would be a period 2 sequence. Then it says, find the value of the sum of this sequence from the first term to the 101st term. So the way to think about that is, well, how many lots of this, period can we get in? Well, we can get 50 lots of 2 into 100, and then there would be 1 remaining at the end. So it would be 50 lots of 3 in the minus 2, or 3, let's just call it 3 minus 2, and then plus the remaining term would just be the 3 again. So that's 3 minus 2 is just 1, so it's 50 times 1 plus the 3, that's 53. Going to question 13, it says we've got this polynomial p of x, use factor theorem to prove, or to show that 2x plus 1 is a factor. So to do that, if that's a factor, then p of minus a half would need to equal 0. Because the factor would be 0, meaning the whole equation would be 0 if it's times 0. So doing p of minus a half, we'd get 4 lots of minus a half cubed plus 8 lots of minus a half squared plus 11 lots of minus a half plus 4. And if you do that in a calculator, you definitely will get 0. Then it says express p of x in the form 2x plus 1 ax. So we're just factorizing out the 2x plus 1. So we can do that with long division. So we're going to divide 2x plus 1 into our cubic 4x cubed plus 8x squared plus 11x plus 4. So 4x cubed divided by 2x, that's going to give us a 2x squared. Multiplying that through onto this, we're going to get a 4x cubed back, and then a plus 2x squared. Subtracting off, we'll get 6x squared, and we'll just bring this 11x down. So plus 11x. Then we repeat that process, so 6x squared divided by the 2x. That gives us a plus 3x, and then multiplying this through onto this, we're going to get the 6x squared back again, and we'd get a plus 3x. Subtracting off one more time, that would be 8x plus 4. 8x divided by 2x, that gives us a plus 4. Multiplying through just to check we get a remainder of 0, we do actually get 8x plus 4 again, and that subtracts off to get the 0. So our p of x is just 2x plus 1 times 2x squared plus 3x plus 4. Then in part C it says, given that n is a positive integer, use your answer to part B to explain why 4n cubed otherwise never prime. Well, prime means the only factors of it could be itself and 1. And conveniently, we've got it in a factorized form. So let's just write it out again. P of x is 2x plus 1 times our 2x squared plus 3x plus 4. And then, oh, sorry, I should have written n. Let's just replace these with n. 2n plus 1, 2n cubed, 3n. So let's think, if n's a positive integer, then it's got to be greater than or equal to 1. So if that's true, then 2n plus 1 must always be greater than or equal to 2. And our cubic there, the quadratic on the end, 2n squared plus 3n plus 4 would always have to be greater than or equal to, well, 2 plus 3 plus 4. That's 9. So it's never going to be a factor of just 1 in itself. It's always going to be have factors bigger than 1. That isn't just itself. So hence never prime. So p of x always has 2 factors greater than 1. Hence not prime. Moving on to question 14, it says the equation x cubed equals e to the power of 6 minus 2x has a single solution x equals alpha. By considering a suitable change of sign, show that alpha lies between 0 and 4. So the change of sign method was thinking about roots of equations, so when the y-coordinate's equal to 0. So we need to reimagine this by just bringing it all to one side. So we'd have x cubed minus e to the 6 minus 2x equals 0. And now rather than thinking about the intersection of these two lines, we can think about the roots of this line. And we can plug in 4 and 0 to see if we get a change of sign. So if we plug in x equals 4, we get 4 cubed minus e to the 6 minus 2 times 4. Using a calculator, what does that give us? 4 cubed minus there's e to the power of not squared, sorry. The power of 6 minus 2 times 4 is 8. That's 63.86. And then if we plug in x equals 0, then we're going to get 0 cubed minus e to the power of 6 minus 0. So just minus e to the 6, which is negative. So change of sign. Therefore, root between 0 and 4, or in this interval. Okay, then it says show that the equation x cubed equals e to the 6 minus 2x can be arranged to give this. Well, the thing I notice is it has a natural log in it. So we're going to want to rearrange for the x in the exponential, because then that would give us the necessity to use a log, right? And it's actually just like, if I rearrange for that, all I'd have to do is cube root. So it's definitely going to be that one. So first, if we use the natural log on this, we would get 6 minus 2x is just the natural log of x cubed. There's no natural log of x cubed in our expression here, so we can use the power rule to bring that 3 out of the log. So that would be 6 minus 2x equals 3 natural log of x. Then we just need to rearrange for the x. So that would be 2x equals 6 minus 3 natural log of x. Dividing by the 2 is going to give us the final answer. Then it says, can we use the iterative formula with the starting iteration being x1 equals 4 to find x2, x3, and x4 to 3 decimal places? So I've got to iterate multiple times. I'm going to set this up nicely in my calculator. So first I'm going to hit 4, hit the execute button, and now that's stored as the answer. So if I want to just keep plugging the answer in, I'll type out my formula, but using the answer button. So I'll have 3 minus 3 over 2 times the natural log of the answer. So I hit that once, and currently the answer is 4. So it's going to give me x2 to be 0.92 to 3 decimal places, 0.921. And then now 0.921 is stored as the answer, so all I have to do is hit execute again, and it will plug it back through for me. So that gives us x3 is 3.124 to 3 decimal places. And then hitting execute one more time, that would be 1.291. Then going to part 2, it says figure 1 below shows a sketch of parts of the graph y equals 3 minus 3 over 2 ln x and y equals x. So we're doing the Cobweb diagram for our thing before. So this is like effectively the y equals x line here, and this is the curve. So each time we plug it into this, and then we can trace it over to the y equals x line, because that's going to give us the new x coordinate to plug it back in again. So just to see what that looks like graphically, so we plug in our first iteration, which was 4, and we plug that into the curve, and then we trace that over to the y equals x line, because that has the property that the y coordinate's the same as the x coordinate. So now I'm at the right x value to actually plug back into the iteration. So it's going to go up here. So that's our first iteration. Then this is our second iteration going up here. So that's x2. Then we can repeat the process again. So this will take us to x3 here. Plug that in. And then we need to do one more. So to the line and back to the curve. So just to check, we go from 4, that takes us to x2 here, then back over here, that takes us to x3, and then back to the left, that takes us to x4, which is what we wanted. Explain why the iterative formula, blah, 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 fails to converge to alpha when the starting value of x1 is 0. Well, if we just look at the formula, there's a problem immediately plugging in 0 because we can't evaluate natural log of 0. So can't evaluate natural log of 0. There's no real number that will give us an answer for that. So moving on to question 15, it says, show that this expression can be rewritten like this. So the first thing I notice is that in our first expression, we've got 2 thetas going on, and our answer's only in terms of thetas. So we're going to want to use double angle formulas to deal with that. So for sine 2 theta, there's only one option. It's 2 sine theta cos theta. So that's going to be 2 sine theta, sine theta cos theta times cosec theta. And if we think about that, that's going to cancel out, the sine and the cosec will cancel out just to give us a cos. So then we're just looking for another 2 cos and a sec remaining. So if we look at the cos 2 theta, we're thinking, well, I've got a few options for that, but ideally I'd like one that just has coses in it, right? Our answer is purely in terms of cos, or sec is 1 over cos. So I would then choose, that's 2 cos squared theta minus 1 as the identity. So if we plug that in, we have 2 cos squared theta minus 1 times sec theta. Then, like I said, this sine theta and cosec will cancel to give us just the 2 cos theta. The cos squared will cancel with the one lot of with the sec to leave us with just 2 cos, so it's a plus of 2 cos. And then we've got minus 1 times sec, so that's just minus sec theta. And then we've got the final answer, 4 cos theta minus sec theta. Carrying over to part B, it says a student is attempting to solve this equation, which is notably the same equation we had a minute ago. Sorry, the same expression, but now it's equal to 3 to make it an equation. They use up their result from part A. So this is their working, and then B part 1 says, explain why the student should reject one of their values for cos theta in step 4. So presumably that means one of the values is okay then. So there's got to be a reason why it doesn't, like they've solved correctly, but there's a reason why it doesn't solve the original equation. So my first thing to worry about is, well, cosec and sec are reciprocal functions, so we have to worry about division by 0. And if we think about, yeah, cos theta equaling 1, so if cos theta equals 1, that means sine theta equals 0. Because, yeah, so cos theta equaling 1, that happens when theta is 0, or 180 degrees. Sorry, or 360 degrees, 0 or 360 degrees. Both of those sine theta is 0, and that's an issue for this guy, because that would be 1 divided by 0, so, and like that doesn't make sense in the original equation. So we'd have to exclude the cos theta equals 1 solution because of that. Then it says state the correct solutions then for the equation. So we're just going to use the solutions he got from this guy. Well, oh, so he's actually given us he's solved it for both. So we can just think about which ones came from cos theta equals 1. Well, we already said earlier that would be 0 and 360. So we don't want those two guys. So we would just want the 104.5 degrees and the 255.5 degrees. Carrying on to question 16, it says figure 2 below shows a 1.5 meter length of pipe. The cross section is of the pipe is shown in the figure 3 below. Then it says, use the trapezium rule with the values shown in the table below to find the best estimate for the volume of the pipe. Okay, well, to calculate the volume, it's going to be the cross-sectional area times the length of the pipe. So first we can get the cross-sectional area with the trapezium rule. So if we remember, or we can get it in the formula booklet, the area from the trapezium rule, that's half h, then it's y0 plus yn plus 2 lots of all the values in between. So first off, our h is the width of each trapezium, so we can see these guys are separated by 0.4, so h is just 0.4. And then the y values are just here, so this guy is y0, this guy is yn, and we're thinking about everything in between. Just check that. Oh, sorry, actually. So notice, actually, this goes from 0 to 2, which is a bit sneaky, because that's only half of it, isn't it? So for us to get our area, we're going to need to take this and double it. So it's going to be this and then times a 2 on the end. But so let's file that through. All the times 2 is going to do is get rid of that and the half. So then we can plug that in the formula, plug our numbers in. So if we go back to the normal section, that's going to be the h, which is the width of the trapezium, is 0.4, times the first y value is -3, plus a 0, so I'll just leave that alone. And then we've got plus 2 lots of all the ones in between. So that's minus 2.943. Oops. Then it's going to be plus, but really another minus 2.752. Then minus a 2.353, minus a 1.572. Close all that off. Close both brackets from the beginning. That gives us a negative, but we got to remember it's just that because it's under the x-axis, so we'll just ignore that. So the area is going to be 8.896. And then what are the units of this? X and Y are measured in centimeters, so we got to watch out for that as well. That's 8.896 centimeters squared. So we need to convert that into meters if we want to use the 1.5. Or I suppose actually we could just convert this into centimeters. That would be easier, wouldn't it, really? Let's do that. So 1.5 meters is 150 centimeters. So the volume is going to be 8.896 times 150. So let's times our answer by 150. Still ignoring the minus sign. That's going to be 1,334.4 meters cubed. Question 17 says the function f is defined by f of x equals the modulus of x plus 1 for x element of the real numbers. The function g is defined by g of x equals natural log of x, where g has its greatest possible domain. Using set notation, state the range of f. So whenever I'm finding a range, I like to just draw a quick sketch. So we think like a regular mod x graph is just a v, like y equals x and y equals minus x stuck together, but then it's all just shifted up by 1. So that means this point here would be 0, 1. So the lowest y coordinate we could get would be 1. So that means the range as a set would be a set of y values such that y is greater than or equal to 1. Then it says state the domain of G. Well, it says G has its greatest domain possible. We can plug in all positive numbers into a natural log. We can't plug in 0 or any negative numbers. So that would just be x is greater than 0. Then part C says the composite function h is given by h of x equals g composed with f. So write down an expression for h of x. So we're just, wherever we see an x in g, we're going to plug in the entirety of f. So that would make h of x just the natural log of the modulus of x plus 1. Then it says determine if h has an inverse. So if it's going to have an inverse, we already know it's a function. So if it's going to have an inverse function, it must be 1-to-1. So it can't be. We already know it's not 1-to-many because it says it's a function. It can't be many-to-1 either. So we need to think about the fact that it can't be many-to-1, which, let's see. So what's happening with this function is we're taking the output from here and plugging it into the natural log, which is already going to be an issue if you think about it. Because if I take, let's say x equals 2, which goes to y equals 2, and minus 2, which also goes to y equals 2. Sorry, it'll go to y equals 3 and 3, excuse me. Then that's going to be two values of x that wind up giving us the same output, isn't it? Like if we think about it, like natural log of mod of 3 plus 1 is going to be equal to natural log of 4. And then natural log of mod of minus 3 plus 1 is also natural log of 4. That means it's many-to-1, meaning the inverse would be 1-to-many, which is not a function. So if our function's many-to-1, therefore it does not have an inverse. Moving on to question 18, it says, use a suitable substitution to show that this integral can be rewritten as this integral. So first off, to give this, I can kind of see it, but to help you guys see, if you're not sure, what substitution would be good, well, their integral has two terms, so we could start by expanding our integral that we're starting with. So if we did that, we'd have 4x times that 2x plus 1 to the half. So that'd be 4x, 2x plus 1 to the half. And it'd be a plus a 2x plus 1 to the half. So what I can kind of think it would be a good idea is if I had u be 2x plus 1, the sign's admittedly wrong at the moment, but it's definitely going to give us a u to the half output once we plug that through. So I'm going to use the substitution u equals 2x plus 1. So if we sub that in, well, we're going to need what x actually is as well. So if we rearrange that for x, that's going to be u minus 1 over 2. So, well, actually, let's do our limits as well first. If we plug in the bottom limit when x is 0, that's going to give us u is 2 times 0 plus 1. So that's 1. And then if we plug in the top limit, that's when x is 4. That's going to be 2 times 4 plus 1, which is 9. So that checks out with the 9 there, so that's promising. Now let's actually plug in. Or actually, let's sort out our differential as well. So if I differentiate this guy, we're going to see that dx du is just a half. So our dx is going to become a half du. And then, yeah, let's actually substitute into our integral now. So this integral, we've already done the limits. The top limit becomes a 9. The bottom limit is going to become a 1. And if we're subbing into this, we've got 4 lots of our u minus 1 over 2 times the 2x plus 1 to the half, which is just this guy. Oops. Just this guy, but square rooted, so that's u to the half. Then plus another 2x plus 1 to the half, so that's just plus another u to the half. And then it's we've got to replace the dx with a du, so that's times a half du. Then let's start to simplify this up. So that's the same as, I can bring the half all the way out because it's multiplying, sorry, that should have been in brackets there, all of that. That half is multiplying everything, so I can bring that all out and be between 1 and 9, the integral. Then if we just expand this guy out, that would be 4u over 2, that's 2u. 4 times minus 1, that's minus 4 over 2 is minus 2. U to the half du. Oh, sorry, not du. We've still got this u to the half here. That's just on its own though, so plus u to the half du. Then expanding out a bit more, well, we can see we've got all the half still there. The 1 and the 9 haven't changed. But we're going to get 2u times the u to the half. That's 2u to the 3 over 2 using our indice rules. And then minus 2 lots of u to the half plus 1 lot of u to the half. That would just be minus u to the half du, which is the integral they asked us to get. Then it says, hence or otherwise, evaluate the integral. Well, we've done the hard work now. All we have to do is do this integral, which is just a power rule. So even if you didn't manage to get the first bit, guys, you could still do part B. That's like something you learned in the first year of A-levels, and it's still 4 marks, so a lot of marks on offer for an easy question. Don't know why that's copied over as well. Let's just tidy that up a bit. So doing this integral, we've got a half, and then we're integrating this, so it's 2u to the 5 over 2 divided by 5 over 2. So that's going to be 4/5 of u to the 5 over 2. And then we've got minus, it's going to be u to the 3 over 2. And dividing by 3 over 2 is the same as multiplying by 2/3. Between the limits of 1 and 9. So plugging that in, that's going to be a half, big bracket. And then, to be honest, I think I'll just let the calculator do the hard work, but I will write it out. It'll be a half of 9 to the 5 over 2 minus 2/5 of 9 to the 3 over 2, which is not that bad. We could just do the square root and the cubing, but I would rather just plug it in the calculator. And then minus the bottom limit. Well, actually, the one limit's easy, because that would be 1 and this would be 1. So let's save ourselves a little bit of work there and just realize that that's second bracket's just 4/5 minus 2/3. And I'm going to type all that in the calculator just to check that it does come out. So 1 over 2. 2 sets of brackets. Then we've got 4/5 of 9 to the 5 over 2. Or let's call it to the 2.5. Minus 2/5 of 9 to the 1.5. Close that. Then minus, open bracket, that's a 3 there, sorry. 4 over 5 minus 2 over 3. Double close all the bracket, like the big bracket as well from the beginning. Oops, what have I done wrong? Sorry, I missed the times sign there. Sorry, just a quick correction there, guys. My handwriting was not very good. So that's a 3 there, not a 5. That's a 3, that's a 3, and that's a 3. So if I go back and correct this to be a 3, then we should get the right answer, and we do. Continuing on to part C, it's now given us the equation we actually were integrating earlier, and says a student uses 4 rectangles to approximate the area under the graph between lines x equals 0 and x equals 4. So he's trying to estimate the integral we did a minute ago, essentially. He said the total area of the 4 rectangles is A, and the student decides to improve their approximation by increasing the number of rectangles. Explain why the value of the student's improved approximation will be greater than A. Well, if he adds more rectangles in, he's going to get some more area, right? If you can imagine, like, putting in more rectangles like this. Like if he halved all the rectangles and then put in the gaps, if that makes sense. So he's going to get some more area. So more rectangles will increase A. But if we think if we add more rectangles in the way he's drawing them here, it's still going to be an underestimate. But will still be an underestimate of the exact value, or the exact 1322 over 15 value. Carrying on to question 19, it says a curve has equation y cubed times e to the 2x plus 2i minus 16x equals k, where k is a constant. The curve has a stationary point on the y-axis, so that means we know when y equals 0, sorry, not y equals 0, on the y-axis would be when x equals 0, we know dy by dx equals 0. Determine the value of k. Well, if we're going to use this information, we're going to need to differentiate, and by the looks of this, we're going to have to differentiate implicitly. I can't really separate my x's from my y's. So let's start with the y cubed e to the 2x. We're going to use the product rule on that. So if u is y cubed, differentiating that, it's going to be the chain rule. So differentiating y gives us a dy by dx, and then y cubed would go to 3y squared. So it would be 3y squared dy by dx, and then v is e to the 2x. So v prime, or derivative of v, is 2e to the 2x. And then using our product rule, we would get u times v dash. That would be 2e to the 2x times y cubed plus 3 e to the 2x y squared times dy by dx. And then differentiating the rest, the 2y would just become a 2 dy by dx. The minus 16x would just become a minus 16. And the k would vanish altogether. So that would be just 0. So let's see what this information tells us now. If we plug in x equals 0 and dy by dx equals 0, well, that's going to make all the dy by dx terms vanish. So these will come to nothing. And it would just be this guy here. So, and the x would be 0. So it would be 2e to the 0 times y cubed minus 16 equals 0. That would be, if we divide it all by 2, because e to the 0 is 1, so we can ignore that. That would give us y cubed equals 8. So that must mean y just equals 2. So now we know that 0, 2 lies on the curve, so it must satisfy this equation. So we can just plug that in, it would tell us k. So we'd have 2 cubed times e to the 0 plus 2 times 2 minus 16 times 0 must equal k. E to the 0 is 1, so that's 8 plus 4 must equal k, or in other words, k equals 12. Carrying on to question 20, a gardener stores rainwater in a cylindrical container. The container has a height of 130 centimeters. So let's get ourselves a little sketch here. So there's my cylinder. The height is 130 centimeters. The gardener empties the water from the container through a hose. The hose is attached 5 centimeters from the bottom. So that's 5 centimeters. That's not very good. Let's make that a bit clearer. 5 centimeters. At t minutes after the hose is switched on, the depth of the water, h centimeters, in the container decreases at a rate which is proportional to h minus 5. So that's saying dh by dt, that's the rate, is proportional to h minus 5. In other words, dh by dt equals a constant times h minus 5, which looks familiar with what they've got here. And they say initially the container of water is full. So that's at t equals 0. They know the h must be, what's h measured in? Centimeters. So the h is 130. And the depth of the water is decreasing at a rate of 1.5 centimeters per minute. So they know also at t equals 0, dh by dt equals 1.5. So if we just use this and the information we were given, so we know 1.5 must equal k times the h at that time, which was 130 minus 5, then we get 125k equals 1.5, and then that's k is 1.5 over 125. So plugging that in the calculator just to check, 1.5 over 125 does give us the 0.012. Sorry, it's a decreasing rate, so I should have had this be a minus, shouldn't I, from the beginning? That's minus, and the minus sign would just carried through. So that would be minus 0.012. Okay. Then it says solve the differential equation. Okay, so we solve all differential equations the same. All the h is going to have to come to the left to be with the dh, and the dt is going to have to go to the right. And we're only allowed to multiply or divide. So it's going to be 1 over h minus 5 dh equals minus 0.012 dt, and then we integrate both sides. So 1 over h minus 5, that's going to integrate to just the natural log of the modulus of h minus 5. And that's just a constant, so that's going to go to minus 0.012 t plus a constant, and we can find the constant because we had some initial conditions. We knew what h was when t equals 0. So we know natural log of 130 minus 5 going to be 0 plus c. In other words, c is going to be the natural log of 125. So let's plug that back into our equation. So we've got the natural log of h minus 5 equals minus 0.012 t plus the natural log of 125. If we want an expression for h in terms of t, we're going to need to remove this log. So let's combine this log with this. So if we subtract it and then use the subtraction rule for logs, we'd have natural log of h minus 5 over 125 equals minus 0.012t. Now just using the definition of a log to convert to the exponential form, we know that h minus 5 would be 125 e as natural log's log base e, the power of minus 0.012t, and then rearranging for h, we're going to have to multiply by the 125 and add the 5. So it'd be 125 e to the minus 0.012t plus 5. Then part C says find the time taken for the container to be half empty. Give your answer to the nearest minute. So half empty, that's when we started at 130. So half empty would be 65 centimeters. So we're looking for t when h equals 65. So if we go back to this equation here, let's copy and paste it, in fact. So 65 would equal 125 e to the minus 0.012t. Then we'd have, plus the 5. If we take the 5 over and divide by 125, we'd have e to the minus 0.012t equals 60 over 125. Then going back using the logarithm, we'd have minus 0.012t, the natural log of 60 over 125. So t is 1 over minus 0.012 times the natural log of 60 over 125. Let's plug that in the calculator. So 1 over minus 0.012 natural log of 60 over 125. That's 61.16. They wanted our answer in to the nearest minute, so let's just check what t was measured in again. T is measured in minutes, actually, so no conversion required. So to the nearest minute, that would be 61 minutes. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.